We were talking about analyzing graphs of polynomial functions, and now we're going to look at identifying even and odd functions. And if we look here, we can see that even functions, number one, have our end behavior both heading in the same direction. So we know that our highest degree for the polynomial is going to be an even degree. So x to the second, x to the fourth, x to the sixth, and so on. The big thing that needs to happen, though, even though it does have an even degree as the highest degree, it has to be symmetric to the y-axis. So what that means is basically the graph needs to be able to be cut by the y-axis and folded over onto itself. Or negative xy and xy are on the same plane. So let's look at some examples for that. So we have an even degree here, which is x to the fourth. But as we can see, this function is not symmetric over the y-axis. This side of the graph goes down well below this side of the graph. So if this graph was an even function, this minimum would have to be down here by this one. But if we take a look at this graph, we can zoom in. We can zoom in again one more time. We see that this one is symmetric. So if we click on this point here and we click on this point here, we see that the y value is the same for a given x distance away. We can also look at our minimums here. We have negative 0.65 and 0.65, and the y value is the same for this. And then obviously they both share the same, both sides of the graph share the same point on the y-axis. Next thing we can look at is we can look at odd functions. And odd functions, yes, the end behavior is finishing in opposite directions. So we know that the highest degree needs to be odd. So x to the first, x cubed, x to the fifth, and then symmetric to the origin. So that means we could rotate around the origin and we would be able to map itself onto the other half of the graph. And we can take a look at some examples. Here we have x cubed. We have to scroll up a little bit. And we can see that this one is symmetric around the origin. So if we rotated this portion of the graph 180 degrees, it would map onto itself. Now, if we change it slightly, if we just say +2, that's going to change what the graph looks like a little bit. Oh, not equals to, +2. Now we can see that the graph is now no longer symmetric around the origin. So the point doesn't go through the origin. So this graph cannot be defined as an odd function. Yes, it has an odd highest degree, but it is not an odd function. We can take a look at this one, and we can see if we look at our local maximum here and our local minimum here, we see that the x value is -2 with a +16, and then over here it's +2 with a -16. So one half of this graph will rotate around and map onto the other half. So this is an odd function.